Hello! Today I will be talking about Unit 2, which is forces.
That sentence had too many syllables. Apologize!
Wait, how'd you even get here? And who are you?
Due to educational purposes, our supervisors have requested that we don't say certain words like...
Am I forgetting anything? Second, to all the students trying to learn Unit 2 forces, I have one question to ask. Explosions?
Wait, what? No, wait, where did you even come from anyway?
Thirdly, I don't have anything third. Let's get back to the video!
So there are three types of forces: static, dynamic, and circular. Static is when either there's a constant velocity or it's not moving, it's in place, and the sum of the forces equals 0. Dynamic is when the object has a acceleration, and circular is when it's moving in a circle and self-explanatory. So yeah.
Hi everybody, Robert Dyer, and today we're going to take a look at another brand new Cheetos product. Cheetos Mix-Ups Extra Cheesy Mix. You have a cheddar, a regular Cheeto, a nacho cheese grid shape, a double cheddar cheese puff, and a Parmesan cheese puff. And of course you have Chester Cheetah here on the front, and another 4 flavors description on the back. And there's the salsa mix. So let's get this bag open and see what's inside. Here comes the cheesy mix-ups out of the package. And you see you got your standard old-fashioned Cheeto here. Got the double cheddar cheese puff. Here's the nacho cheese grid shape. Does have a little bit of a nacho Doritos aroma. And finally the Parmesan cheese puff, which does have a little bit of a Parmesan aroma. So let's see how these taste. I'm going to give the Cheetos Mix-Ups Extra Cheesy Mix 3 stars. You get 4 very high quality chips in here, but the only problem is that only 2 of them were extra cheesy. You gave me half. The problem is the name of the chip is extra cheesy, and the Cheetos and the cheese puffs are just that, pretty much the standard flavors. I didn't detect any double in the double cheddar at all. However, the Parmesan cheese puff does have a real Parmesan taste, which is unusual for a flavor in a chip. So I'd give that one 5 stars. And the nacho grid shape was very reminiscent of the Nacho Bugles from many years ago. Also a great flavor and 5 stars. So overall, this is definitely worth getting for those 2 Parmesan and nacho flavors, but it doesn't deliver 100% on the extra cheesy label. So I hope you like this video, share it with your friends, subscribe, and I'll see you next time. Bye everybody.
So here's all the static equations. We have the force is equal to mass times acceleration. We have the force of gravity equal to mass times gravity, which is 9.8. We have force of friction equal to mu, which is the frictional constant that they should give you, or you can solve for it. Mu times mg, which we already figured out there. This is force of gravity, and it is equal to big G, which is 6.67 times 10 to the negative 11th, times mass of one times mass of the other, over r squared, r being the distance between the 2 objects' different centers.
Shut up! That's not how you teach static equations. This is how you teach static equations. Ah! Force equals mass times acceleration. Force of gravity equals mass times gravity. Force of friction equals mu times mu. Mass times gravity. Force of gravity equals gravity times mass 1, mass 2 over r squared. Force equals mass times acceleration. F equal ma is the most important equation in all of Unit 2. Now, just so you can get a visual, look at all these muscles. This is mass. Now, watch me accelerate. This is force!
So some more equations are the force of spring, which is equal to negative kx, k being the spring constant and x being the distance of compression. Another one is the sum of force on a circular object being the mass times the velocity squared over the radius of the path. Another one is the centrifugal acceleration, which is v squared over r. If you can see, that's part of this equation. And the velocity is equal to 2 pi r over the period. P being the period, by the way. This is the torque, and torque is equal to the radius of the pivot point times force applied, and L is the angular momentum time. That is equal to mass times radius times v, and wind is picking up here. So yeah, it's gonna be a good day. I did that one. So these are all the equations for Unit 2.
Now these are all the equations on fire!
So A to Unit 2 is force of tension is equal to force of gravity. We can say this because the mass on this side is going to be going downward, so this will then pull this side upward. That is simply just 10 times 10, giving you 100 newtons. This is a free body diagram giving us different forces in the equation. We have the force of tension going this way. We have the force of friction pulling in the opposite direction of the movement. We have the force of gravity pulling downward, but we can also subdivide that in gravity.
Hello and welcome to the middle of the film, the moment where we take a break and invite you, the audience, to join us, the filmmakers, in Find the Fish. We're going to show you a scene from another film and ask you to guess where the fish is. But if you think you know, don't keep it to yourselves. Yell out so that all the cinema can hear you. So here we are with Find the Fish.
邊個做㗎？我數3聲。1 係我做嘅。
In the y direction and gravity in the x direction, and we can also have the force of force normal, which is also in the y direction. Does this go? Okay, so we are trying to find the frictional force acting on the box in the plane. To do this, we get the force tension, which we found up here, and we subtract that from the force of gravity x, which we can use by multiplying the force times the sine theta. Sine theta being 60 degrees and force being 100 newtons. We then get 13.39745 as the answer. To determine the unbalanced force, all we have to do is add the force of gravity x and the, wait, no, that's not add. Never mind. Sorry. Okay. To determine the unbalanced force, we subtract the force of friction by the force of gravity x. This gets you a 73.205 newtons. We can say that the force normal and the negative force in the y direction is unneeded because they equal each other, canceling each other out. To do this problem, first we have to find the acceleration. Acceleration is equal to force divided by the mass, giving you a 7.3205, and then we put that into a kinematic equation. The equation v squared equals v squared 1 plus 2ad. We then put in all the numbers for that, and then we get v is equal to 5.412875 millimeters per second, mass per second. I don't know. Statics. So I have a triangle with a 30-degree angle and a box sitting on top of it. I can show you this free body diagram of the force normal going upward, force gravity in the y direction going down, force gravity in x direction going this way, and force gravity in, force friction going this way. So if the force normal and the force y are equal, then that means the box will not float into the sky, which is very good. So I can either make the force gravity x minus the force friction, giving me ma, so that would make it move down or up or whatever, or I could do the force gravity is equal to force of friction, making it stay at rest without moving, giving me a sum of force of 0. Circular forces. 1. So I'm ice skating around a Christmas tree at 2 meters per second. I have a mass of 420 kilograms, and I'm ice skating around it with a radius of 20 meters. I then put that into my circular force equation with mass times velocity squared over r. I plug in those numbers and I get 84 newtons of force going around a sweet Christmas tree.
Force equals mass times acceleration. Force of gravity equals mass times gravity. M being mass and G being the gravitational constant, 9.8 meters per second squared. Force of friction equals mu times mg, mu being the coefficient of friction. The force of gravity on other planets equals g times m1 m2 over r squared, g being 6.67 times 10 to the negative 11, and r being the distance between objects. Remember, kids, hydrate. Sincerely believe this is fucking awesome!
So we've covered statics, dynamics, and also circular forces.
And explosive forces!
No, we're not doing that!
Explosions!
No!
Just a few helpful tips from Explosion Man.